All right, so my name is Michael Keeling. We're going to talk a little bit today about finding your way in the software wilderness. And I want to use this as kind of this idea of like moving metaphor for exploring some big ideas with how we do that. Okay, so I mean, every software system that we build basically turns into a gnarly, nasty, funky jungle with like barbs and vines and traps and probably tigers and all kinds of stuff spread throughout the place. Yet somehow, at least some people are able to kind of find their way through this jungle, and they're actually able to be quite successful, even though it's a kind of gnarled mess. Even this picture is kind of interesting because you can kind of see perhaps there's like a trail here that somebody laid at some point or that was created over time. And so, yeah, there are paths through these jungles, and we're going to talk about some ways that we can move through them. Yeah, why are some people, this isn't displaying here for some reason, which is kind of a bummer, but why are some people better at navigating through these software systems than others? Okay. So a little bit of context, which I think we've already talked a little bit about that. I am working at Lending Home currently. I did write a book on software design, and probably for the past 7 years or so, I was working at IBM, which is where most of the stories and things that I'm going to talk about tonight are going to be coming from. So let's see here. Yeah, there's also a lot of the ideas from tonight you can find in the book as well. And then I guess as far as like training and things like that, I come from Carnegie Mellon, which is, I don't know, where a lot of the software architecture types of ideas were kind of codified initially. So that's a little bit about me. And what we're going to do tonight is explore this hypothesis. So humans navigate through abstract landscapes using a similar kind of cognitive approach as what they would use through a physical landscape. So the way we move through the world, okay, in the real world, we can use similar strategies or similar ideas to apply to software, okay? And to kind of answer that hypothesis, two questions we're going to go through for this talk. How do people do that? And then once we kind of figure out how people do that, what does that mean for software, okay? All right, so let's dive into this first one here. I wish that was working. So the big question, so when you're going from point A to point B, so when you were traveling here from wherever you were coming from to get to the code and supply building, what was going on in your head to allow you to get here? How did you actually navigate to this place? There's kind of two prevailing cognitive theories for how that happens. This theory of cognitive maps, so you have a map in your head, or landmarks. So you're able to kind of see the world as if they're kind of pictures or snapshots. Okay, and let's kind of see what that means here. So imagine you're out in the woods taking a hike and you're trying to figure out how to get to some cabin, deep in the woods. Okay, from the kind of cognitive maps view of the world, from that theory, what scientists have kind of hypothesized is you've got a map in your head and you're able to kind of see that as if you're looking from a bird's eye view, right, at the world, and you're able to kind of orient yourself and kind of see where you're going, right? So this hiker might be saying, oh, well, based on the angle of the sun and where I am in the woods, I'm about 300 meters east of the cabin, so I need to, turn right or something like that. Okay, so this kind of bird's eye view, top-down view of the world, kind of like what you would see on like Google Maps or something like that, right? An alternative theory that has been proposed is this idea of cognitive landmarks, or this idea that you're taking snapshots of the world as you move through it. Okay, and that's actually what we're using to decide how to get from point A to point B. So the same hiker might say, oh, well, you take a left at the sign, and then you walk until you find a rock with a T painted on it, and then you hike up the mountain, and then the cabin is, next to the waterfall, right? And then that's how you would describe how to get to this location, not using this map, but these snapshots of the world, the actual world itself. Okay, so humans can't tell us what's going on in their heads, but rats, they can't tell us either. But we can perform experiments on rats, and a lot easier than we can on humans. Okay, and so to kind of put this question of how do we figure out where we're going, put this to the test, we've done some experiments on rats. So specifically, they devised this experiment called the Morris water maze, where they fill a tank with water, drop the rat in, and it's able to kind of swim around and find the goal. Okay, let's see this experiment specifically. So there's our friendly little rat and our Morris water maze. Basically, so we start by filling the tank with opaque, kind of milky white water. as you saw in that previous picture. It's supposed to be a very specific temperature, humane for the rat, all that kind of stuff. But fill the tank with opaque water, and then just below the surface, where the rat can't see it under the milky water, there's a platform. That's the goal, the safety point. Okay. For this particular experiment, we're then going to put reference points around the outside of the water maze. Okay. And let's see here. So then we're going to hide a portion of the maze, so the rat never really sees that section, and then we train the rat. Okay, so we drop the rat in the tank, and it will swim to the goal, and eventually over time it's able to get there directly, very quickly. It knows exactly how to get there. All right. At this point, the rat has kind of learned the maze. All right, but they've only seen part of it. So now what's going on in this little guy's brain? Okay, so back to these two theories. Has the rat built this kind of bird's eye view, a cognitive map of this maze, and is that how it's figuring out how to get around? Or alternatively, has it looked and said, oh, well, next to the triangle, and then I swim to the square, and then there's the platform, right? Is it building snapshots to kind of get through the world? So to put this to the test, this hidden area of the maze, we show it, and then we drop the rat off in this new mysterious location. Okay, so the rat's never seen this before. The theory here is that if the rat has built this cognitive map, it's not going to care where it is in the tank, if it's seen it before or not. It's going to be able to orient, identify, where in this kind of bird's eye view of the world it is, and then know exactly how to get to its goal. Okay? Or if it's doing snapshots, it's going to say, oh, well, I've never seen a triangle from this angle before. I don't know where I am, and it's going to behave as if it is as if it's a completely new maze. All right, and sure enough, that's basically what happened. The rat, when dropped in the new section, became completely disoriented. It was as if it was a new maze entirely. And as a conclusion of this experiment and many others, building up more support for this idea of cognitive landmarks. Okay, using cognitive landmarks for navigation. All right, we've done this, people have done the same experiment with honeybees. Okay, so they've taken honeybees and placed their hives in specific locations, allowed them to find food sources, and then they rotate the hives, and the bees just get all kinds of lost, which is pretty interesting. We have actually done this experiment on humans too. So through virtual reality, able to put different landmarks and different arrangements to show that people can get lost just as easily as rats and bees. So that's pretty cool as well. We're going to do an experiment right now on all of you, just to make sure that this is actually true what I'm saying. So I'm going to show a picture of objects. I'd like you to memorize those objects. I'm then going to cover the objects, remove one of them, and then you have to tell me what has been removed. All right? So fair enough? You can just yell it out when you have it. So let's give this a try. All right, so we're going to cover it, remove one. And I can already see Anastas is like, oh, I got this. All right, car.
I have no idea.
No idea? All right, car was removed, so it was the car that time. So we're going to do this again. It's not exactly a perfect experiment, same set of objects. All right, ready for it? All right, let's remove one. Yes, so we had one right answer very quickly, one wrong answer very quickly, a bunch of hesitant people jumping back and forth. I played a trick on everybody on that one. So you were using the kind of spatial location, the landmarks within that grid to identify which objects were there. It was significantly more difficult just by a slight rotation. It was just one rotation, right? And threw people off a little bit. Yeah, all right, so there you go, landmarks. We navigate using landmarks, cognitive landmarks, building snapshots of the world. So great, fantastic, so what? How does this relate to software? So let's try and connect this back to some interesting ideas about architecture and how we can design architectures better, okay? So back to this original hypothesis. So what I'm proposing is that we use these same ideas to go through these abstract landscapes such as architecture that we use through physical landscapes. So knowing that we need some kind of cognitive landmarks, we can now apply this to software architecture, hopefully. So the big key here, right? Why is this important? The big key is, if you can't navigate through the architecture effectively, you're more likely to cause trouble. Okay, get lost within the system and cause trouble, and this is bad for a number of reasons. Yeah, there you go. Likely to cause some trouble there. You could be doing things like violating the architecture in different ways. You could be introducing complexity that didn't need to be there. Possibly blowing up quality attributes like performance or maintainability or testability, just because you don't know where you are or where you're going. So we want to prevent that from happening. So for us, animation didn't work there. For us, the whole idea is we don't want to be like hacking through the jungle with machetes, right? We want to be much more controlled and specific about how we're going through things and guiding people, guiding our team with us to kind of go through the system. Okay. Let's see here. Yeah, and the big key with this, I can't see the landmarks that are in your head, so we have to figure out ways to get those ideas out of your head and into your teammates' heads so that everybody can be successful moving around. All right. So there's a number of different ways that we can do that. A lot of times we do talk about maps, and that's basically one of the predominant metaphors that we teach with architecture, right? We talk about these kind of top-down views or these high-level views. We even call them 50,000-foot views pretty frequently. We'll talk about how you can have a zoomed-out view. You can zoom in to see different aspects of the system. We talk about being able to apply different views or different layers onto the architecture for different perspectives, right? So this is a topographic view of Pittsburgh. There's another view of Pittsburgh, this one for specific stakeholders, maybe a tourist or something, right, who wants to be touring downtown. Architecture diagrams themselves, we even put legends on them, just like maps, right? So this is something that is very much ingrained in the way we do things. And I think that's good, but there's something that the best software designers are doing when they see these maps. They're somehow extracting something different, or they're internalizing ideas that are not present in those maps. Okay, so what we're going to explore here now are some alternatives to this idea of architectural cartography. Okay, so we want to try and do some different things. 4 things we're going to talk about over the next couple of minutes here. So how we're going to, maybe some different strategies for creating snapshots. We're going to talk about different ways of leaving traces, and I'll explain what that means in a minute. We'll briefly talk about telling stories and kind of the importance of storytelling. And then finally, we'll explore some ideas of how we might live in the architecture, kind of bring it into the physical world, which is probably the least explored in this talk, but it's something cool to think about. So yeah, before we get into that though, I do want to share some context. So these stories are coming specifically from my team at IBM. We're a team of about 9 engineers or so, give or take a little bit. Varying backgrounds, varying levels of experience. We were doing like Scrum with some XP style practices, that kind of stuff. The reason I bring that up is as you're here listening to these things, that's the context that we were in. So keep that in mind to kind of translate it into your own context. And I'm happy to kind of talk about specific ideas for that afterwards, for however for whatever format your team is in, right? However you guys are organized. For us, we were doing the kind of traditional, I don't know if there is a traditional one, but microservices with a large group of people across Watson. Probably one of the more challenging environments I've seen anyway, from like a security and governance perspective. Both good and bad, I guess. So keep that in mind as well. Yeah, and so for us, we had like we were one team among probably 5 or 6 across a pretty broad area. Okay, so just some context as we're exploring these ideas. Okay, so snapshots. So recall back. So when we're talking about these cognitive landmarks, these snapshots, we're talking about kind of a first-person view of the world. Turn right at the sign, turn left at the tree, and you'll arrive at your destination. Okay. I want to emphasize this idea. Maps are not necessarily bad. They're just not sufficient in all cases. Okay. So let's see some ways that we can use maps and kind of inject some more of this thinking for us here. Okay. So what we want is views of our the architectural views that we're producing, we want to be able to see those landmarks that are within them, okay? So they should be showing us some kind of reference points for people to use. This is actually, we were ragging on this a little bit earlier, this is actually a pretty good map from that idea. It's highlighting some of these different key landmarks downtown. So you could say to somebody, oh, go to the stadium and then turn left and then walk by the river and you'll find the casino or something, right? So I don't know, pretty interesting example. This diagram as drawn is not giving us any of that kind of stuff, but we can modify it in a couple of interesting ways to kind of start to make these ideas more concrete. So kind of hidden in this thing, we've got a simple kind of tiered pattern right off the bat. And this diagram was drawn this way to be able to pull out that tiered pattern. And in fact, the way that I'm referencing that now, when we talk about this amongst our team, you will see people moving their hands and gesturing, in different ways as if there is a top to bottom structure. Okay, so that's kind of the first key thing. Patterns are landmarks, and we want to be able to highlight them within the different views that we're producing. Okay, so there's lots of different patterns, whatever it is, layers, tiers, pub, sub, peer-to-peer, pick your poison, okay, pick a pattern, or invent your own. It really doesn't matter. The main thing is whatever your patterns are that you're using, make sure that they're obvious in some way in the diagrams that you're producing, okay? All right, there's another kind of hidden landmark here, which I think is kind of interesting, and that is that we have different teams working on different portions of the system, or we did at one time. By kind of arranging, we could have arranged these things within the horizontal tiers in many different ways. With this particular arrangement, though, it's very easy to kind of see a reference point of where I am in the world and who might be working on which parts of the system. I don't have the other diagrams that kind of go with this series of work here, but we would try and keep things in the same kind of positioning, even within the diagrams themselves, as you're moving through different parts of the system, which is kind of interesting. Okay, so if you can help people see where their work applies, they're going to be able to internalize what they're doing a lot better, okay? And that's a simple thing that we can do in these diagrams. All right, another thing that we can do is applying different views to kind of bring more context to different things. So this is not super visible from here, but that's okay. Dark is bad, all right, we'll just say that. If you're able to show things like, these are the good components, these are the bad components, how good or how bad, whatever that may mean. In this case, we're looking at like technical debt. This is giving you a reference point that you can then use for having conversations, say, about the evolution of the system, how to get from point A to point B, right? So in this case, we removed one of the worst components to make way for a simpler future, right? Okay. So yeah, we want our views to have these relatable reference points. So however you get them in there. Color is one way, notations are another. Lots of different options with that. This is just one example. Okay. Let's see here. Yeah, okay. So I think this chunk is, I think, a little more interesting. So we'll get into this. So the next thing that I think that my team at IBM did really well is we leave traces, okay? Leave traces for others to follow. This idea comes from this fantastic book called On Trails. I strongly encourage you to pick it up, especially if you're an outdoor enthusiast. It's very good. But Robert Moore basically defines this idea of a trace as a visible mark left by the passage of a person or animal. So as you're moving through the world, we're leaving traces as we go, footprints or scratches or bits or something. Over time, right, if we leave enough traces, then we start to kind of carve out trails for others to follow, which is why these traces are interesting. Okay, this picture. This is interesting because there's actually a number of traces that we can see just in this one picture, both man-made and human-made, and also, well, I guess all human-made. Some intentional and some accidental, I guess would be the best way to put it. So, first most obvious one, somebody stuck a sign here, turn here, right? A very important kind of marker that was left. There's off to the side a blaze, right? So another mark that was left for people to kind of see and follow. A little more subtle, but also important. And then probably the most subtle in this case is you can actually see just a little bit where people, through their footsteps, were starting to carve out a trail in the ground. Okay, so these are the types of traces that we want to try and figure out how to leave within our software systems, right, as architects, so that people can actually find the architecture. Architects leave tons of traces, or at least I hope most architects are. The first, probably most important one is in the code itself, right? This is our number one most important opportunity for leaving some kind of trail, some kind of trace for the architecture, right? Is within the code itself. There's lots and lots of different ways, lots of strategies to do this, and I'm not going to go into any of them tonight, but these sure would be great topics for future Code and Supply meetups. Architecturally evident coding style is probably one of the more important ideas. It has to do with making these structures that we draw on whiteboards actually apparent in the code. So if you call a thing a business layer, oh, well, maybe you should have a package called business layer, right? It sounds easy. People don't do it, right? And probably the biggest offender is the util, the junk drawer of all things, right? The slow deterioration of the architecture that way. You can leave comments to describe rationale. You can leave comments within your version control history to like describe the evolution of the system over time. I'm a huge fan of using testing, and I kind of call it domain-centric design. I don't really want to pigeonhole this into like DDD, domain-driven design, but taking kind of a problem-first perspective or a domain kind of first perspective on your architecture itself is a fantastic way to kind of create these connections and leave these traces. Okay. If you are interested in these topics, these two books are great resources that you should check out. Just Enough Software Architecture by George Fairbanks. He kind of coined and researched a lot of these ideas. And then Simon Brown with the Software Architecture for Developers has done a great job expanding on it and really, really making it a core practice. Okay, a practice that I want to talk about tonight that we've been using for quite a while on my team at IBM was architecture decision records, and I assume those are still flying around occasionally. Okay, so there have been new ones since I left. That's a great sign.
We set a new record for number of comments.
Oh, that's wonderful on an ADR. All right, so architecture decision record. So basically, it's a short text file short text file that describes the set of forces and a single decision in response to those forces. So we're looking at recording a single idea, context around that idea, and rationale for kind of why it came to be. You know, why do we care? All right. This idea has been around, I should point this out, for 25 years or more. It becomes cool every 5 to 7 years. So we're on maybe the fourth wave of coolness for recording decisions. It seems to be the one that's finally sticking. So that's a good sign, I think. All right, let's see an example to make this a little more concrete. So here's an ADR, pretty simple one. It says use the pipe and filter library, right? So we basically said we're going to use a library to enforce a architectural pattern pipe and filter, right? So we're strongly enforcing it, right? It's short, right? There's not much to this. It's less than a page if we were to actually print it out. A couple of pieces of this. So the context, the kind of forces at play are described at the top. The decision itself, just a one sentence, we will do something. And then the consequences. As a result of this decision, here are the positive and negative effects that might happen. Okay, and I think we zoom in on some of these. So I don't know if there's anything interesting we absolutely need to go through. Yeah, so we're talking about things like how the team has behaved to different ideas in the past, right? So maybe the skills in the team and things like that. We're talking about available libraries. We're talking about, the use of the pattern in the past and the kind of the technical fitness of the pattern and things like that. Blah, 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 blah. The decision, super simple. We will use the pipe and filter library to organize application logic. So not too interesting or surprising. Status is one of those things I think, well, we've been experimenting with it a little bit, or we had been, maybe it's continued still. But basically, a decision can be accepted, or it can be deprecated, or it can be proposed, right? If it's an idea that you just want to capture, things like that. I think the consequences are much more interesting, probably the most important part of the whole thing. So here we're getting into things about really the quality attributes that we're trying to promote. So how did this influence the testability of the system? It looks like we're talking about things like observability with logging and metrics here, right? yeah, reliability. So there's some reliability concerns, it looks like in this bottom one, about uncaught conditions or errors. I don't know, some interesting stuff. I think this is available on the web and other places as well. Lots of info on ADRs right now out there, so that's cool. Over time, as we're checking these things into the version control system, we start to get a record of all the different design decisions that were made, which is pretty darn cool for leaving trails, right? Creating little traces as you go, and then leaving trails for other software developers to follow behind you and kind of understand what's happening. So kind of a neat side effect. Yeah, I don't know if I'm going to go into all the. Yeah, we'll go into some detail. I guess so. A side benefit of what we found with this particular technique, also great for training, which is kind of cool. So you can see each one of these colors represents the ADRs contributed, the decisions being made effectively by different developers on the team. And really what this is showing us is, in the beginning, it was basically just me. And then slowly over time, I was making fewer and fewer decisions, and more teammates were getting involved. So this is a fantastic way to get more people involved in the design process, but then also increase kind of confidence training and lots of other really great things. And eventually it came to the point where the vast majority of things were coming from other people. So yeah, what is it? I think I contributed just this little tiny sliver, maybe two, and then everyone else was contributing significantly more. So that's pretty cool, and we can see that over time just by mining the Git logs, which is kind of neat. All right, so yeah, the whole theory here, if we leave enough traces in the system through architecturally evident coding styles, through design records, many other techniques, then, well, we'll eventually start to blaze some trails that are going to show people how to promote maintainability or how to promote modifiability, how to move through the system, which is pretty darn cool. All right. So, telling stories. Right, so, I didn't have the slide I thought I did. So I've got this slide instead. The big question, so when we're doing all these great things, we're leaving traces, we're making views that show things that are happening, how in the heck do people find out about these things or know that they should be looking for them? The way we do things, or the way we did things when I was there, and I'm sure it still is happening, was telling stories, lots and lots of stories. So we use sticky notes. We redraw those views continuously. Anytime we need to talk about something, we're at a whiteboard kind of drawing. Kind of building out these stories about how the system came to be, why it is the way that it is, and describing to each other what it looks like. Some of the techniques that we use for kind of helping to encourage this kind of storytelling. So we are focusing on the user very strongly. Okay, so that's probably the most important thing, is always having that kind of problem first or kind of user-centric kind of view of the world. We do a lot of sketching. So architecture is abstract by nature, right? It doesn't really, structures don't really exist until you make them manifest in some way. Drawing is a really great way to make them concrete. So you really need to be sketching a lot. Observing my IBM team at work, we would take turns, which I thought was very interesting. So it wouldn't just be me telling the story all the time. It would be, hey, Eitan, why don't you tell so-and-so how it happens? And then maybe I would just listen, right? Or we would go through a round of explaining how a certain decision would be made and what we would do about it. And then we'd say, okay, Joe, why don't you play it back? Tell us what we just decided, right? So this kind of turn-taking kind of activity. Trying to use the traces that we made to kind of encourage people to follow those where we could. And one thing that I really liked about what we did is just asking questions, and that is really a bit of an art, or you really need to practice learning how to ask questions and creating an environment where it's safe and okay to ask dumb questions, right? Because we need those dumb questions to be asked to make sure that we actually know what we're talking about. So constantly kind of questioning and challenging what's going on. All right. So the storytelling and all this is great for creating this kind of oral history. And there's a really fantastic chapter in that On Trails book that talks about different Native American tribes keeping oral histories alive for generations, right? To the point where some of the Native Americans displaced to reservations were able to, generations later, come back to where they were originally from, and still were able to walk through like the mountains of Appalachia and know where to go, which is just amazing. These oral histories collapse if we don't work to keep them alive. So it's something that we have to constantly continue to work on and constantly kind of keep going. And this is something that I'm interested, I'm going to give it away. I want to come back and visit you guys, my team, in say 6 to 8 months and see what actually works. If how well those oral histories are still alive. Right, so you have to kind of build this culture and continue kind of encouraging the storytelling to keep those things going. All right, so last little bit here. So living in your architecture, are there different ways that we can do this? So we've been talking about landmarks and things, and are there ways that we can bring these landmarks into the physical space? And this was my desk at the IBM office, and there actually is some evidence that this is possible to kind of bring these ideas into the space. So from where I sat in the office, the architecture basically became kind of real. So if I would look to the right, I would see Anastas, for example, working on different pieces of the query components, different search algorithms. I would see Jenny working on something having to do with some of our REST facades, right? Another piece of the architecture. And then way back in the corner, I would see Chuck freaking out over something having to do with the platform crashing, knowing that all of our DevOps pipelines have probably just exploded, right? So based on who I saw talking to whom and who was moving around where, I could see the dependencies within our system. I could see new connections being made. I could see different ways that the code was actually coming together, which I thought was pretty neat. Looking over to the left, it was the same thing. So, I'd be able to see Joe or Eitan freaking out about something having to do with the training aspects of our system, either crashing or going down, or maybe bringing in some new functionality, right, depending on who is talking to them. And then way back in the corner, you can kind of see through the window, would be our offering team, the product managers. And probably most importantly with them is if they're not at their desks, you got to be worried because they're probably off talking to some executives and coming up with amazing new features that we don't have time to build. So it was good to kind of keep an eye on them, even though it didn't necessarily have to do with the architecture, the business drivers, I guess. But yeah. All right, so I don't know. That's kind of the only way that I've one of the only observations I've seen about bringing these systems, these designs that we make into the real world, which I thought was interesting. But I think there's a lot more that could be done, right? So maybe we could start playing with physical manipulatives, right? So these are the organic chemistry kits that people play with to help teach chemistry in high school and college. The Lego Serious Play workshops are pretty interesting for exploring business concepts. I wonder if we could be doing something with this to make our architectures manifest in reality in the physical space a little bit more. Let's see here. 3D printing has been around and affordable for quite a while. I have no idea if it would be possible to print a view of the architecture, but it would be certainly interesting to explore that idea. Oh man, wouldn't it be cool if we could like actually go into the computer in some way, right? Like in Tron, be like walking around and be like, oh yes, Flynn, my architecture looks beautiful today. And we'll go, oh no, architecture violation, right? And we'll just get zapped to heck. Anyway, so I think that would be wonderful. But it's also not that far off, right? So things like that we see in Iron Man, being able to have 3D representations are not super crazy, given a lot of the advances in stuff like HoloLens or the Magic Leap mixed reality headsets and things. So there's some cool stuff that could be happening, maybe for software, the way we design systems, the way we communicate with each other. I don't know of too many people who are experimenting with these things right now. So I leave these here kind of as a seed, maybe to get people thinking about that kind of stuff a little bit. All right, so let's wrap it up. So we explore two questions. How do people navigate through the world? And then how can we use this knowledge to design our architectures better? We kind of came from this hypothesis that, well, humans are going to go through abstract landscapes in a similar way as they do physical landscapes. And we learned about some of the cognitive theory behind that, and that we are actually moving through the world using cognitive landmarks, okay, not kind of these maps. So the fact that we present the world, our architecture is oftentimes in maps, but people seem to need landmarks, could explain why some teams are able to get away with creating so little documentation. They're just doing a really good job of building those landmarks, or at least translating those maps in some way. So we need to do more of that kind of stuff, and maybe less of the other things. Yeah, so this is me speculating at this point, the best architects could be translating the software systems into these landmarks. I don't know of a good way to test that, but it does seem very, very plausible that that's what's happening. The one catch with all this, so design is kind of limited by our imaginations a little bit, right? So we can do practically anything, which means the landscapes are basically infinite. So we do need to think about how to constrain them in different ways. And that's where ideas like using patterns or trying to make them concrete through drawing comes in. Right, so, and then, coming up with exploring different ways such as ADRs for leaving traces as well. Many, many different ways to do that. What I hope is that you'll take a few things away from this for creating some landmarks in your code or in your system, or at least finding the things that are already there and highlighting them in some way. I think it's a huge opportunity for improving the designs and improving communication. And with that, I hope you did get a few things to put in your silver toolbox. And thank you very much. Go for it, sure.
The first thought I had about the landscapes versus landmarks, or landmarks versus maps. It is also true from cognitive science that we do have parts of our brain that respond to locations. Absolutely, they're called place cells. Mm-hmm. And one way, I would argue that this I think is really interesting and very accurate. But we use landmarks to construct maps. So this is one. It seems like this is talking about one phase of that landscape making. And from there, what do you think there's anything interesting to comment on there? Like, do we care about what the final map ends up being? How accurate does it need to be? Things like that.
Yeah, so there's, you're right, there's like multiple layers deeper of cognitive science that I do not know squat about. So I'll just throw that out there. I'm a software engineer. I do recall from some of the research I was doing that it does lead to some kind of map building, but the idea, I think, is the starting point is very, very different, right? Rather than starting from the map. I don't know that I have any other intelligent comments, but I could say some unintelligent ones, I guess. Yeah, there's a lot more to explore, I think, with this topic. But yes.
Sorry, hopefully you have your questions are okay. Thank you.
Oh, too. Always.
Is the PowerPoint available somewhere for reviewing, or is it proprietary?
No, we'll figure out where to put it.
Okay.
We'll stick it somewhere, I guess. Yeah, we'll make it available. Yes.
I think it's worth pointing out that cognitive landmarks and maps serve two really different purposes. And that we can observe that rats and other creatures use landmarks to navigate themselves, but how does one rat tell another rat how to find that platform?
Well, rats, I don't know tell anybody, but yeah.
They can't draw maps.
Well, and they can't talk either, but right. I think that's an interesting question that we should be asking ourselves. Right, I think that's what we need to be asking ourselves. So what I am challenging is the idea that I can just draw a map and just drop it on you and then expect you to necessarily be able to figure everything out. And it's going to be challenging, and you're going to get things wrong, which maybe is okay, or maybe we can make it easier for you to kind of develop that firsthand experience, I guess, as you're using that map navigating for the first time, building your own snapshots, right? And you are 100% correct. I don't want to make it sound like, oh, never draw diagrams, baby out with the bathwater. Absolutely not. We need both of these ideas. We need the maps, but we also need to acknowledge that there are other things that can help us communicate more effectively and share these ideas more effectively, of which I think landmarks are one idea, and there's probably many, many others. Does that jive with your experience? Cool. So I think I saw a hand in the back, maybe?
I was going to say, I think it's wrong to say that we only use maps to communicate. If you want people to be able to solve open-ended tasks, a map presents a large amount of information in ways which they can apply intelligence to derive landmarks for then matching up as they navigate. If you want to provide guidance for a specific task, your map is going to look a lot like a sequence of landmarks. It's going to be, look for this, look for that. So if you're teaching people how to bring up a cluster or whatever, and common things to look out for as things are going wrong, you're going to be documenting some of the landmarks. And when people ask for directions, they don't want you to draw them a map, they ask for the basic landmarks they use to get to a place, because it's a very task-specific set of steps to be followed.
Right. Right, and yeah, I think that idea of kind of what are your goals, where are you trying to go, what are you trying to make sure happens, right? And then context is always important, right? So even as you're giving, is that true necessarily? Yeah, sure. So some of the hiking pictures that I showed were from a trip that we took to Norway a number of years ago, where we had maps that were not useful in that particular case, but the written instructions in like broken English, because we had run it through translators and stuff from Norwegian, turned out to be fantastic. And it said things like, turn at the sign and walk till you find a giant rock and things like that. We had a very kind of mission-oriented kind of goal in that case, right, of like getting to a specific location. And I think for when we're talking about like pattern seekers or explorers and things like that, probably a different set of skills maybe come to play. But then the question is like, how do you share that information when you get back? I don't know, kind of interesting. So, yeah, go ahead.
So kind of possibly related thought, like one of the things, at least in my experience, that makes maps about 500 times more useful is that you are here icon. Like if you've ever seen a shopping mall map and you're like, I don't know what this is saying, and then they're like, oh, you're standing next to the elevator, and you're like, now I get it. And that seems to kind of help you track the map to the landmarks, right? So you see the elevator next to you and the elevator on the map, and you're like, right, there it is. So is there kind of a you are here analogy you feel in your model?
Yeah, I tried to show some examples of that. I think a lot of that's going to depend on the size of the system and the task or the goal at hand or what you're trying to promote. I don't know, there's different ways that you could try and capture it. But.
Actually, I would like to make a comment on the UR here because I've actually used that.
Oh, awesome.
And what I've done is I've used that actually when I've had more of a longer term vision on how an architecture is to evolve over time. And I've literally put, okay, this stuff is shaded, being that it doesn't exist yet, or stuff like that to show different ways that the architecture's to evolve over time.
Yeah, there's lots of, notations, color, the animations, like making multiple pictures, lots of different, I think, ways to do it, which is pretty cool.
I was wondering, are there, I was specifically asking about keeping oral history, and with teams that are more agile oriented and less document heavy, that's one of the biggest problems, and keeping the oral history within the team. And I'm wondering if there are any, or in your experience, if there are any known solutions as to how to keep that oral history with teams that have high turnover, a high turnover rate, or teams that are not document heavy.
Yeah, so the high turnover rate is definitely a challenge, and that's something with Lending Home, where I am now, that I think is kind of interesting. They're They've been around for about 4 years now, and a couple of years ago they saw some significant turnover with, I don't know, things in San Francisco being the way San Francisco is, to the point where there's only a handful of people left who kind of know the core, right? Which is cool, but also terrifying, right? So rebuilding the oral history is a big deal that's going on right now. So the knowing who those people are, I think, is very important. What would be the word? Like linchpins, right? The kind of central points who kind of know what is going on is very, very important. These guys are sick of me saying it, but I think pair programming is probably the #1 superpower of all software development. So getting people working together and kind of talking to one another as they're making decisions and doing things. And then I've been a huge fan of the architecture decision records. We've been using them for about 2 years, maybe a little bit longer now, and they've been, I think, pretty interesting and pretty successful in at least keeping a thread of something that would give, even if you don't have much context, an entry point maybe.
Sort of like the things
So
that
lightweight documentation.
Yeah, the things that you kind of mentioned like complement each other. And
Exactly.
none of them is standalone by itself.
Right, exactly. So kind of the working theory that I have with this stuff is there's probably 4 or 5, maybe 6 different things that are super lightweight and can be very, very natural for what you're doing. And if you're doing all those things together, then it all just kind of works. If you're only doing ADRs, it's probably not going to work. If you're only doing pair programming or something, it's probably not going to work. But if you're doing all these different ideas together, it seems to kind of create these bonus multipliers that make architecture a lot easier to deal with without having to write the big documents and things like that. Yes.
Right in that you were talking about document heavy. I'm writing out basically I've been in the process of writing a 5-year plan of architecture for 100 developers of an enterprise system, which is definitely a level above normal. I have maybe 10 actual documents. You don't have to be that document heavy. You just have to have the right ones and get key holders understanding and distributing the information.
I bet you talk to a lot of people though. You probably talk to a lot of people, right?
I talk to a lot of people.
Yeah. So he's one of those people that holds it together, right? Constantly telling stories and showing and sharing and describing and explaining and keeping it all alive. So yeah.
From the landmark and overhead approaches, do you see either ones being more advantageous for older legacy software? Like even the difference of the maps between like Pittsburgh and San Francisco you showed. Like San Francisco is a newer city and based on more of a grid, whereas Pittsburgh is kind of a hodgepodge of different municipalities from 300 years past. Do you think that you might be able to go towards one theory for like something from the 60s as compared to something that you're designing from scratch today?
Yeah, I don't know. I don't have much firsthand experience with massively legacy systems. I think the things that I've been working with, there's always been somebody around who can kind of describe what's going on. So there's some things that I'd be interested to explore around architectural reconstruction. So especially with respect to like storytelling. So being able to go in and almost like not an archaeologist, an anthropologist, almost like an anthropologist of observing the way people are working and getting people to tell you the stories and kind of slowly recreating what's going on. I think things like that might work, but I don't really know. And then to the point in the back, like it's not about big documents, right? And it's not even about lightweight things. It's about the right combination of things for your group, right? So I think with legacy systems, you have that trick that some of the things like architecturally evident coding styles or bringing in testing to help kind of frame the architecture in, those aren't really going to be options, right? So that kind of does constrain the world a bit, which would leave things like documentation, right, to kind of warn people where things are, or describe what's happening. Right?
I actually have a lot of experience with that.
Oh, awesome. Let's listen to the expert.
What you just said does work a lot. Listening, going around, listening to people, sitting with users and seeing how they work in a system, especially when there's no oral history. The other thing that I found that works is injecting tracer, just logging, inserting as many log statements into your code as you can in test, and just running through stuff, and literally, especially in a, make sure it's single threaded, make sure it's, so you're not getting, too much overhead, but injecting, log messages and or, using a debugger and just seeing what happens. and then mapping that out.
Yeah, architecture reconstruction is an interesting topic. And, that's definitely like a core strategy of like observing the running system,
Yes.
which is pretty cool. Can be difficult, but very cool. Oh, yes.
I just have a comment on what just was being discussed. I had the experience of being in a team 10, 15 years ago, where the entire company basically went bankrupt, everyone left, the entire intellectual property left, and a team had to reconstruct the architecture from, like what you said, traces here and there.
Yeah, I'm sure that was very challenging. So yeah, my experience so far, and one of the things I am excited about being at Lending Home is being now in the different position, right? So the last couple of years I was very focused on trying to leave those traces, build those trails, and now kind of going into a different kind of world, being dropped into a new jungle basically, and trying to find my way around is kind of exciting.
I'd like to add a comment about the general topic, which is a lot of the ways people are distinguishing between doing legacy systems and other systems. We are currently writing legacy systems. And so what sticks out to me is that this is a way of avoiding having made these legacy systems that are impenetrable.
So I mean,
So that's, or one
there's
approach
legacy
to
systems
it.
and then there's legacy systems, right? So like the classic Michael Feathers definition is like, you know, a software system without tests, right? So when you're dropped into a place and you've got like no tests around it and you also don't really know the code at all, that's way different than, oh, what idiot wrote this? Oh God, it was me like 6 weeks ago, right? That's a different kind of legacy, I think, than I think what these gentlemen were referring to.
We'll take 2 more questions.
Very good.
So since you pulled up the thing for cognitive science, the other thing this makes me think of is like the relation in cognitive science between understanding something and being able to compress it in your mind. To analogize with a computer, and this feels very relevant, that like all those diagrams, et cetera, that those are helping people develop that mental compression that goes with understanding something.
Yeah, that sounds really interesting. I'd love to see you explore that more.
Talk idea.
Yeah. January's open.
All right, one more question.
Do you think Pittsburgh produces better software architects because we give physical directions by landmarks?
Yeah, but that's the problem. The old burned down McDonald's, right?
The old burned down McDonald's is right. Legacy systems. I don't know.
Landmarks no longer exist.
It's definitely something to think about. Definitely something to think about.